Alright, today on 15 processes of blacksmithing, we've broken out the coal forge and we're going to do a little bit of forge welding and forge braising and just discuss kind of how the processes work and what's going on. Right now I've just made a little fold over with a little bit of taper on that back end so that you don't get a cold shut or a difficult to form weld, and this should go really nicely as a little lack. What I'm trying to do here is just bring up my fire nice and slowly. This is a unfluxed weld, so if I have my fire running just right, I should be able to bring it up to temperature without too much problem. I'm looking into the fire, just watching my steel, seeing what it's doing, watching it come up in temperature, and I'm turning it so that it's getting heat from all sides. Everyone always makes forge welding out to be witchcraft, and it is pretty tricky if you don't know what you're looking for, but after a while you start seeing it, and the lower or closer to the forge welding temperature bottom range you can get your material, the better.
What temperatures are we looking at here?
That's a really good question. It kind of depends on the alloy, but generally you're in the 2000-ish. Somewhere in that ballpark, sometimes a little higher, sometimes a little lower. You know, some folks are talking about getting forge welds at even lower temperatures. There we go. Woo! That's actually a little hotter than I wanted, but that'll work. When you come in for the weld set, don't get overexcited. You just need to come in and gently work it through. And that actually welded up quite nicely.
That was very exciting.
A little bit more exciting than I was hoping for, but...
So you can still see the seam.
Yep.
But it is stuck together.
Yep.
And that was no flux. So how do you do it with no flux? Why does that work?
The little bit of witchcraft on this is how fire functions. So if we say that down here, this is the bottom of my fire pot, and if you're doing the side blast, so the air is coming in this way, it's essentially the same thing. So whether your air is coming in from the side or from below, it doesn't matter. You wind up with this area here. This is your primary fire center. It's the core of the fire. And then outside of that, however your fire might be formed, something like this, you now have, and generally down in this lower area isn't getting hot, and same over here. So you wind up with this kind of canopy that comes over the top. And this is your very, very core. This is where the air is. So this is what we call the oxidizing. I'm just going to put ox there. So that's the oxidizing zone. This zone here is basically where everything has combusted perfectly and you have all the heat, but you're not having excess oxygen or excess carbon. And then outside of that is the third bubble, which is the carb zone. So this is what they used to refer to, or maybe somebody still does, as the carburizing zone. This doesn't really exist in solid fuel. It's nonsense. There's no way for us to absorb carbon from it. But if you were in say an oxyacetylene torch, that would be more appropriate. So ideally, this is the bubble right here that you want to put your material. If you put your material too low, you're going to get the oxidizing zone, and then you'll actually get sparkles within the fire, right? If you're in this zone, there is no free oxygen to cause oxidation of the steel, so you will not get sparklers. And if you're up here, it's probably too cold and you'll never get up to forge welding temperature anyway.
So, can you explain to them what flux does?
What flux does is it becomes a barrier to your oxygen.
Right.
And generally we use borax, white silica sand, and then 10,000 combinations of random other things that you can add to it, subtract from it, in order to create the perfect zero oxygen environment.
Right. So
you could literally use up ground up glass bottles if you wanted to.
So flux is not a glue. It is just something that prevents the steel from oxidizing while in the fire. Just to clear that up for everybody.
And if you actually leave the steel in there for too long, so here you can see I've got a pretty solid little weld. I could go through multiple passes on it, but it's a pretty solid little weld. It's actually welded up into that top lap. Got a little bit of opening over there, which I could dress in. If I'd left it in too long, you start getting the oxidizing. And maybe I'll do that on purpose later and actually burn a piece so that you can see that in the common problems issue. And when you burn it, you have now changed the chemical construct of your beautiful, perfectly milled iron or steel. And at that point, you're best off either grinding out that mess that you've made or starting again. Because trying to get that stuff to glue back together when you've actually got that burnt up steel is never going to work. You basically have this goopy nastiness. Can you get it to work? Yes, absolutely. There's always those plausibilities that you can force something to happen, but it's a whole lot of hard work for pretty crappy results. So bring it up to temperature, nice and easy. And this is the thing, you want to do this, and then when it is yay far from your welding temperature, crank up the air just a little bit, let it peak, hold, allow it to have that full soak onto the anvil, work it quick, but light. I took a lovely class with Elmer Rausch, and most of you probably never heard of Elmer, but he is literally our grandfather on Viking era blacksmithing. He's freaking amazing. You watch him forge weld and it's just a delight. But he has a hammer that he only uses for forge welding, and it's about 1.5 pounds, and he hits it very, very gently. Don't come in with a massive hammer and start smashing it, because what will actually happen is you'll break that seal. What's actually occurring when you're forge welding is you have managed to remove all the oxides, all the silicates, and you've got them into solution or into liquid matter. And at that point, your iron is naked, and it's in an environment temperature-wise that it is free to bond together. So with force and with heat, you can create this environment, and then you squish the two together, the silicates and the oxides squirt out, which is what you get spraying out everywhere, and those two pieces just go, and it's like 2 bits of modeling clay. So if you take 2 bits of modeling clay, here's a fun one. You have 2 bits of modeling clay like this, and they're, all nasty and dusty. You know that they're not going to stick together well. But if you have them and you fold them up nicely and just tap them together and they're not all dusty, pretty much unlike this here, you see what it does? I still get that crease. And here, where you have that lip at the back end, that is one of the most difficult joints to create, and you often get peel out. So just be aware of those things. It's kind of the nature of it. But with 2-3 gentle work throughs on your weld seam, should be good. All right. Anyway, that's forge welding in a nutshell. And forge brazing, that's a whole nother kettle of fish altogether.